Stand on a beach in Bali, look east. On a clear morning, you can see another island, Lombok, sitting just 35 kilometers away, close enough that you can make out the shape of its volcano. The ocean between them is calm, blue, and completely unremarkable. Behind you, tigers move through the forests of Southeast Asia. Orangutans navigate canopies that stretch all the way to the Indian subcontinent. Elephants, rhinoceroses, hornbills, the animals of Asia, here for millions of years. Now take a boat, cross those 35 kilometers, everything changes. The animals on the other side don't belong to Asia. They belong to Australia. Wallabies move through the undergrowth, cockatoos call from the canopy. Species that have been separated from what you just left for so long that the gap between them has become total. No wall, no visible barrier, no ridge breaking the surface, just open ocean, 35 kilometers wide. And yet this is one of the sharpest biological borders ever discovered. A line so precise that 10 kilometers east means crossing from one evolutionary experiment into a completely different one. It runs through the heart of Indonesia, invisible, ancient, and absolute. The question isn't just what this line is. The question is why nothing has crossed it in 25 million years. The man who found this line wasn't looking for one. Alfred Russel Wallace arrived in the Indonesian archipelago in 1854, 31 years old, with a collector's net and a hunger for specimens that had already driven him across South America and cost him a shipwreck that destroyed 4 years of work. He made a deal with himself. The East Indies would pay back what the Amazon took. For 8 years he moved from island to island, collecting everything: insects, birds, mammals, shells. Over 125,000 specimens sent back to London, and in 1856, comparing the birds from Bali against the birds from Lombok, something stopped him cold. The species weren't just different, they were from entirely different worlds. The birds on Bali belonged to Asian families, the same groups found across India and mainland Asia. The birds on Lombok belonged to Australian families, the same groups found in New Guinea and the continent beyond. 35 kilometers of water. Two completely separate biological histories face to face. He described it in a letter as one of the most striking facts in the distribution of living things. He didn't know why, but he knew the line was real. The answer had nothing to do with the birds. It had everything to do with what was happening far beneath the ocean floor. 15 million years before Wallace was born, two enormous tectonic plates were moving toward each other. The Asian plate sliding southeast, the Australian plate pushing north. The edge of the Australian plate dove beneath Asia, crumpling the crust and driving volcanic islands up from the seafloor. The plates came close enough to create an archipelago, a necklace of stepping stones stretching from Sumatra to Papua, but they never closed the gap completely. Between them, a deep ocean trench remained, one that would never drain, not even when the planet froze. Here is what ice ages do to geography. When enough water locks away at the poles, global sea levels fall. During the last ice age, which ended about 11,000 years ago, sea levels dropped roughly 120 meters, on a shallow continental shelf that exposes an entire country of dry land. In Southeast Asia, it created Sundaland, a continent that connected Borneo, Sumatra, Java, and the Malay Peninsula into a single landmass larger than India. Tigers walked from the mainland to what is now Bali without touching the sea. The full pageant of Asian megafauna, elephants, deer, wild cattle, orangutans, roamed a continent that no modern map shows. On the other side, Australia and New Guinea merged into Sahul, where kangaroos and wombats ruled a territory twice the size of modern Australia. But between Sundaland and Sahul, the trench held. The Lombok Strait sits directly over the collision zone of two tectonic plates. Even at the height of the Ice Age, even with sea levels down 120 meters, the Lombok Strait was still hundreds of meters deep. Still open, still impassable, 35 kilometers. For a tiger, that is the Pacific Ocean. For an elephant, a wall with no door. These animals reach the shore, and the shore is where their world ends. So for 25 million years, two evolutionary experiments ran in parallel, separated by nothing more than the depth of a geological accident. On the Asian side, west of the line, the fauna looks connected to the rest of the planet. Tigers, leopards, rhinoceroses, elephants, hornbills, pheasants, descended from ancestors that moved across ancient land bridges when the continents sat in different positions. Familiar, in a deep evolutionary sense. Cross the line, the mammals are pouched. Marsupials, animals that give birth to tiny, barely formed young and carry them in external pouches, thrived on the Australian side. In most of the world, placental mammals pushed marsupials out 65 million years ago. But, on the Australian plate, cut off from that global competition, marsupials filled every role. They became wallabies, possums, cuscuses, sugar gliders, a parallel mammal fauna built on a completely different reproductive blueprint. The birds are unlike anything in Asia. Birds of paradise evolved in isolation on the Australian side, and evolution, given 30 million years without significant competition, produced plumage so extreme that Darwin struggled to explain it. Tail feathers stretching 1.5 meters, head crests shaped like geometric designs, males that spend years mastering dances of ritualized precision. Darwin called them the most beautiful objects in the world and admitted they nearly broke his theory. Natural selection should favor efficient survival, and yet here was a creature that favored pure spectacle above all else. They work in a world where no predator sophisticated enough to exploit the cost of a 2-meter tail ever evolved. The obvious question, why didn't birds simply fly across 35 kilometers? Some did. Fruit bats crossed the line regularly following seasonal fruiting trees. A handful of bird species established populations on both sides. Rats made the crossing on floating debris, but for every species that crossed, tens of thousands didn't. Crossing is only the first problem. A tigress arriving on Lombok after a 35-kilometer swim faces a world with no prey she recognizes, no males within range. Even if she survives, the lineage ends with her. Crossing a biogeographical boundary requires a breeding population arriving at the same time, into habitat that can support them. In 25 million years, that combination almost never occurred on its own. But in the gap between the two worlds, something stranger was taking shape. The islands of Wallacea, Sulawesi, Flores, Timor, the Maluku Islands, occupy the transition zone, too far from Asia to receive its full fauna, too far from Australia to receive its full fauna, and isolated long enough to produce something neither side anticipated. Sulawesi is the strangest island on Earth. From above, it looks like a letter K that survived an earthquake, 4 peninsulas radiating from a central mountain spine, each carrying the geological memory of a separate island that collided and fused over millions of years. The result is an endemism that rivals the Galapagos. The Anoa shrank. Its ancestor arrived from Asia, probably a full-size buffalo, and began evolving in a world where large body size was a liability. Smaller animals need less food, so it shrank, generation by generation, until what remained stood barely 80 centimeters at the shoulder. A buffalo the size of a large dog, with the horns and temperament of something that used to be much bigger. The babirusa grew tusks through its own face. The upper canine teeth pierce upward through the skin of the snout and continue growing in a slow spiral, sometimes curling back toward the skull. The leading theory, they evolved as eye protection during fights between males. A pig that spent millions of years in isolation developing a face-piercing defense mechanism. A problem solved in a way no other animal on Earth ever tried. These animals exist because evolution, given no other option, invented them. On the island of Komodo, the largest living lizard on Earth reaches 3 meters and 160 kilograms. It kills prey far larger than itself, deer, pigs, water buffalo, using venom that disrupts blood clotting, then follows its prey at a patient walk. It detects a carcass from 10 kilometers away using a tongue that reads the air like a sensor. It exists here because of the Wallace Line. Komodo dragon ancestors crossed from the Australian side during a period of lower sea levels, arriving on islands too small to support large mammalian carnivores, but large enough for a cold-blooded predator that needs a fraction of the food. With no competition from mammal apex predators, size increased. The result is an animal with no parallel anywhere else on Earth, a reptilian apex predator living in the overlap zone between two biological hemispheres. It is not a prehistoric survivor, it is a thoroughly modern animal, shaped entirely by the accident of the line. For 25 million years the line held. Then, roughly 50,000 years ago, something new appeared on the Asian side. It arrived by boat. The first humans to cross the Wallace Line were Homo sapiens, behaviorally modern, tool-using, capable of deliberate planning in ways no large animal had managed. They crossed on purpose. And when they reached the Australian continent, the megafauna they found had spent millions of years evolving without any sophisticated predator capable of planning a hunt. Diprotodons, wombat-like creatures the size of hippopotamuses, giant kangaroos standing 3 meters tall, a marsupial lion with the most powerful bite of any mammal that ever lived. None recognized the threat. Within 10,000 years, most of the Australian megafauna was gone. The line had stopped tigers and elephants for 25 million years. It did not stop the one species that could build a boat. Today, the crossing happens constantly and far more quietly. Every cargo ship moving through the Lombok Strait carries stowaways, rats in the hull, seeds in ballast water, insects in wooden crates. The brown tree snake reached Guam in military cargo after the Second World War and eliminated 12 of the island's 13 native forest bird species within 50 years. Species that evolved in isolation for millions of years had no defense against a predator they had never encountered. The Wallace Line still exists. But every decade, hundreds of species cross it, not by swimming or flying or evolving across 30 million years of geological patience, but by hiding in shipping containers. The separation that took 25 million years to build is coming apart. Wallace came home from 8 years in these islands with more than specimens. He came home with the understanding that geography is not a backdrop to the story of life. Geography is the story. The 35 kilometers between Bali and Lombok look like nothing on a map, but that gap is the reason the bird of paradise exists, the reason the anoa is a buffalo the size of a dog, the reason the babirusa grew tusks through its own face. The line is still there. The ocean between them is still rising. What happens to a 25 million year old border when the geology that created it begins to shift? Biology has not had to answer that question yet. If the story of life at the edge of two worlds stays with you, there is another boundary even stranger than this one, a place where evolution did not just divide the world, it reversed it entirely. Subscribe, and we go there next.